Hi everyone, this is Raju from Smart AI Technologies. Today we will see how to recognize facial emotions using deep learning. Before moving further into the concept, we will see how final result will be look like. So whatever you are watching at, this is the result from our deep learning model, which is predicted on some images. Say some you can see that some images are predicted wrong. Like for true, it was fear, but our model predicted surprise. But you can see for all other images, it is predicting very real. For some, it is predicting wrong. Why? Because I trained it for only 10 epochs. You can make it to 50 epochs or 100 epochs, where you can increase the accuracy. You can see our accuracy is from 50 above 60, okay, and testing accuracy is above 50 or like that. But if you train it more than 50 epoch or nearly 100 epochs, you will get accuracy of 90 and 85, so that you will get good results. You will be getting predicted these results right. So this is what in the end we will be getting the result. But before moving to the code, now let's start from the base. If you didn't subscribe yet, subscribe and like our channel. You will be getting more videos like this. What is facial recognition? Facial recognition is a technique from which we can use a face of a person first and then his emotions based on the deep learning model which we trained for. So here the thing is simple. If there are 100 people in the images or a video, we'll first detect 100 images of the people and then we'll try to detect the emotion of that person. We call this as an facial emotion detection. Why we need recognizing the facial emotion? Driver alert system using smart camera. We can always try to cover the face of the driver and always try to get the emotion of that person. And whenever his emotion is sleepy, try to alert him and wake him up with some buzzer and some sound. This feels silly, but it is having a great applications in the real world. Why? Because so many accidents will happen in the night because of the sleepiness of the drivers and like that. The second title I'm going to give is review for any food in hotels. Here, uh, a review system can be done on any service for a hotel. How it will happen is, for example, there are 100 people who are sitting in the hotel. Okay, now you are feeding some food to them. Now, if the food tastes them very great, what will be their expression be like? You can't go and ask, okay, how was my food to all 100 people, but you can take the information from here. You can directly get to know based on their emotions. Okay, our service, what was the service and how they are accepting it, whether service was good, whether the food was nice. You can take all these reviews directly from the clients without asking them. Okay, this is one of the good feature and where it will be helpful for so many people, and you can they can apply this thing in supermarkets or big cloth centers or like anywhere where customers are a key. And our third application is a deep interview process. Here, normally in interviews, many people will ask questions and answers will be given by the person or client or a student. Okay, but in nowadays, what is happening is it's very hard to understand the person character from the emotion of the face. But so many studies are done while someone is answering to our question, his facial emotion will itself answer us how and what is the way he is living and about himself. Okay, well, positive or negativeness of him can be predicted with the emotion of the face to the questions that you are going to ask, particular questions that you are going to ask. So this is uh, one of the best technology if we apply it properly. Our fourth application is games. Games are using this feature. Here what happens is, if a person is playing a game, in some situations he will be very happy, in some situation he will be very sad. Okay, here what a game company should do is, they should collect the data of a person who is playing the game, wherever he is happy, in which situation he is happy. It should try to create that situation a lot. If the game is able to make that person more happier, you will play that game more. So it will be very profitable to that company. Hi everyone, this is Raju from Smart AI Technologies. Today we will see a concept called how to detect a facial emotion using deep learning. So now we will start with coding. Yeah, you can see on the screen. First I will show you the result. First I am feeding angry1.jpg to my model. Okay, so how is this image? You can see how this is that image, whatever the input image I am feeding now, angry1.jpg. When I feed this image to my deep learning model, so it's predicting and giving that it is fear. Oh, okay, sorry. Oh, I am feeding fear on .jpg. That is this image. It's saying fear action. I feed into my model, which is properly able to say in the end. Okay, it belongs to a class called fear. Using this, whatever you can do. Okay, I will tell you how you can feed this to a live video or live cam, or import some recorded video and you can apply this. That I will be making a separate video in the sequence, but before that, in this video we will see how we are building the model and how we are importing the dataset, how we are pre-processing the dataset. All the steps will go one by one. Let us move on to screen and let us start. Our first part of the project is import the libraries required. Here, first I am importing OS, Glob, NumPy, Matplotlib, Seaborn, Pandas. After that I am going to import scikit-learn and TensorFlow and Keras related models, libraries. So here I will tell a bit about all these libraries, what are they and how they work and what are the need of them in our work. So the first thing is OS, operating system. It is used to access any operating system related objectives like maybe files, folders, cameras, microphone, like that. And then comes Glob. Glob is actually used to get access of the details of any folder or file. Okay, and then comes NumPy. NumPy is actually used to work with arrays and matrices. So then comes Seaborn and Matplotlib. These two are used to plot the graphs or plot the images. Seaborn is specially for only for graphs, which is having so many options to build good graphs or colorful graphs. And then comes the pandas. Using pandas, what we are going to do is you can import any external datasets, say txt file, csv file, or excel sheet, or you can create new dataset, or we call it as a data frame using the data available with us. Then we are going to use scikit-learn to split the data for training and testing. So to do that, we are using a function called train underscore test underscore split. Then comes image data generator. About this I will explain in depth next in the video, so follow. And model, okay, whatever the libraries comes from here, okay, from TensorFlow and Keras, we will be using it below. I will explain what are they and what is that preprocess input libraries, what are the layers like convolution 2D, maxwell 2D, all the layers, okay, where we are going to use that layer, all the libraries from here we will be explaining you bit later in this video. So let us start with first import the data set. For that I am mentioning the path from which path I am going to import it. Mine is train. You can see it in folder. Okay, all the classes are there in a folder called train, so I am importing that first. Now I'm checking what are the classes are there. I have 7 classes with me. So what are they? Disgust, neutral, fear, sad, surprise, angry, happy. Okay, these are all the classes that we have. And then globe. As I mentioned, using globe, I am entering 2 times slash. It means I am entering first into folders of the train, next into subfolders of the train. Okay, and I'm getting all the paths of the images. When I do that, I will get complete file path. It means I will get path of each and every image in the folder. Then comes label. What is labels? How we are getting this? Here you can see, here above we are getting all the complete path of the images. Now there after 10 what is there? Discussed is there. Okay, when you scroll down a bit down, we'll see neutral. It means there above itself there are classes. This 28027 image belongs to neutral. It means this, if I want to know the label of this image, I just need to extract this part from that path file. That's what I am doing. I am reading each and every element of the file path from above, and I am splitting that particular part what I want. That I am taking and making it as an list. I am making it as a label. Then I will create a data frame. Data frame nothing but I will create those two lists into a columns, and I will make it as a data frame. Now which can be accessed using pandas, and we can process on it with pandas. Now I just want to know how many number of images are there in each class. But when we see that, I think happy class is having so many images. It's more than, like, it's nearly 7,000 images. But when it comes to discussed, we have very less number of images. So this data set is purely unbalanced. Here I am not going to explain you how to balance and how to get good accuracies. Okay, that will be a separate video where I will try to help you what is the importance of balancing the data set to get better accuracy and less loss. So here I am going with the flow. Okay, I am taking this data and I am moving as it is. So then I am splitting the data for train and test in the ratio of 75 and 25. If you don't know what is train split and test split, you can contact us. Otherwise, I explained in some other videos of my channel. You can go there and you can get it. Okay. Otherwise, I will share a link of some video in the end or in description. You can visit there and you will get to know. I explained with a clear example. Okay, what is a train split and test split. Okay, here I am going to split my data for testing to 25%, my training to 75%. Here I am defining the random state 42. Why? Because I just don't want the data as it is. I just want to mix up the data rows. After discussed, it's neutral. After neutral, it will be anger. Okay, when I split some data, same data will split 30% of same or 70% of same data will split down. I don't want that. So before splitting, I will mix up and I will split the data. That is the reason we are using that random state. And I'm just printing out some examples to show how they are, how the inputs are. Okay, you can see them. Then I am using image data generator. Okay, here I made a video where I shown like what is the importance for image augmentation to increase the accuracy of any deep learning model, that we can watch. Otherwise I will share the link in the below description or in the I button. Okay, you can watch it. Okay, here what I am doing is I am taking that image and pre-processing the image. That pre-processing is defined by pre-process input, the function which I defined above, which I imported above. Okay, using this I am defining what that image data generator will do. It will resize the image, it will flip, it will transpose, like that. There are some set of particular functions it will do. To know about this more, you can visit that video in the I button which I am showing above, or you can visit from the link below given. So then using that I am creating, here I am converting all the images to arrays. That's what you can directly say using a function called image data generator. This image data generator I am giving to a variable called train gen and test gen. To that function I am feeding my data. Train data I am feeding and test data I am feeding. I am feeding my data to that function, which now converts my data, my images, to size 100 cross 100. Okay, and it will batch the data into 32. Okay, and then once it comes out of that, like images out of this trained data set that flow from directory, this trained data set will now be a set of arrays. Okay, they will be images, but they will be in the form of complete arrays now, multi-dimensional arrays, that is 100 cross 100 cross 3. So till now whatever we did, that was the pre-processing part of the work. Now whatever we are going to do is building the model. Here we are doing transfer learning. What is transfer learning? First of all, transfer learning is a way of training the old model which is trained for some other process. In our case ResNet 50, that ResNet 50 is trained on 1000 classes of ImageNet data set that we are going to use, which is trained for huge number of data that we are going to use, and we will going to train it for our data, that is 7 classes of emotions. Okay, this we will do because it will increase the accuracy. I will give an example to understand it better way. There is one person who know karate and there is one person who don't know anything about martial art. If you are asked to train both of them for kung fu, who will learn better? A person who knew karate will learn better than the person 2. He may learn, but he will take more time than the person A. That's general example. The same thing happens here. If you use some model which is trained for something great and you are using it for our purpose, it will learn faster than the model which you build it from the base. That's why we are going to use transfer learning, and we are going to use ResNet 50 which is trained for 1000 classes of an ImageNet data set. There we need to define and we need to say that model, okay, which is trained for 1000 classes, we need to take and we should transform something so that we can make it according to our requirements. So in our case what we'll do, we'll first define our size of image 100 class 3, and then we'll say in the final we need only 7 outputs. That's what you can see here as a dense layer, output layer. So this is how we are defining it. Once we define the model, okay, once we define the model here, there we imported a model function above. This model is used to create models out of the layers or whatever we define. Now we will bundle that and we will make it a proper model. To do that we are using that model library. So then we are going to compile that model library whatever we want. We are using Adam optimizer, loss categorical cross entropy or binary cross entropy is fine because sorry, in our case it's 7 classes, so we should use categorical cross entropy. If we have 2 classes anywhere, we can use binary. Okay, then I am defining metrics as an accuracy, and then my callback function here what I am saying, what is the importance of my callback function is that if my validation accuracy while training it's not increasing about 2% in 2 epochs. Okay, while I am training it for 100 epoch, at 50 epoch or 51 epoch, if validation accuracy is not changing a lot, then I will say stop there itself and save that model. Don't go further. If you go further also, you will not be getting your accuracy increase. That's just a waste of time. It's way of telling like that. Then I'm going to fit the model. Here I used only for 10 epochs. You should use it for 50 or 100 epoch. And here my callback function, I'm not calling my callback function here, you can call that function also. My callback function you can define here and it will work on it. Okay, I'm removing that my callback function because I want my model to be trained for 10 epochs. 10 epoch is very less. While I am doing it for 10 epochs, I am getting validation accuracy 51%. If you do for 50 epoch, you will get more than 85, nearly 90-95 accuracy without any fail. And if you watch our other video augmentation, like what is the importance of augmentation to increase the accuracy, then if you watch that video and if you implement that here, you'll get good results, far good results than whatever the thing now is. Now I'm going to save that model and I'm going to print what are the accuracy and losses during training and during validation or testing. Now I am going to do validation, particularly remaining 50, like whatever the data I kept for validation, using that if I validate, then also I am getting 51% of accuracy on that data. Now I am going to generate a report. This is the most important step here. Here I am going to generate a report which says what is the precision score, what is the recall score, what is the F1 score, and what is the support score for all the classes. About this I will be making a separate video where it will contain what is confusion matrix and its parameters. These are all the parameters are the equations out of the confusion matrix. Confusion matrix is a way of analyzing any model, so that I will be making different video very soon, and that will be very helpful for you. I think all these are the equations: precision score, recall, F1 score, support. They are all equations. Okay, and for now you need to keep it in mind one thing: precision score is almost equal to accuracy. If we have best precision score, we can say the model is good. Here you can see the results and some random images I am plotting. The titles given, that is like what was the true one, like true was fear, then what is the predicted from our model. Okay, both of them I am printing out, okay, to show you that how accurately it's working. It was trained for 10 epoch and it was nearly 50% accuracy. Then we are seeing so many wrong results here. And after that I am need to, like, I am doing what I am doing is I'm just feeding one images separately. Here you can see first I am feeding angry one.jpg. It means the image which shows angry emotion, that I am feeding it to my model. Then it shows 63% it belongs to first class. What is first class in our case? Under train, first class is angry. That is like our model is properly predicting, like most percent, 63% possibility that image belongs to angry class. Now I am going to import that saved model. Okay, whatever the model ResNet model I saved, that I am going to import it here. Then I am feeding another image like figure1.jpg. Why I am doing is whether the saved model when I import is properly working or not, to check that I am doing this stuff. I am feeding fear image. Once I feed the fear image, it says 89% it belongs to third class. What is the third class here? That is fear. Okay, now I get this matrix. Now out of that what I will do is I will get the maximum one. Maximum is 89. What is its index? Its index is 3. Okay, it means 2. It will start from 0, no? 0, 1, 2. 2 is the index. Then I will compare what is the index of my list, this list. 2 nothing but fear. Then I will print out the fear. You can take that and take this and you can integrate it to any user interface. Maybe you can integrate it with Tkinter interface or web interface, and you can deploy it. So this was all about the work. uh, in further videos you will see some good concepts. So if you like this video, subscribe and like our channel, and see other videos. Okay, I will be sharing some links which will be very helpful, especially that augmentation video. Yeah, thank you very much. We'll see in next video.